It's the year 4323. Humans have explored every nook and corner of our star systems. We've visited each available planet, their moons, and even other star systems. But humanity keeps expanding. That said, if humans can build something as remarkable as a man-made island, what's stopping us from doing something of the like, or something bigger than we could hardly imagine? Apparently, more advanced aliens could, at least according to scientists. This means we could too. That's why we're taking a journey to the far future to witness artificial structures built in space. So what are those, and what do we know about them so far? More than that, what would life be like there? Before we embark on our journey to the future, there are a few things you should know. Throughout the 20th century, many scientists and science fiction writers conceived of massive structures that could be built to colonize space, encompass an entire planet, and even an entire star system, which is collectively known as megastructures. And that's what we've set out to see today. Now, we've traveled as far as the year 4425, and we have megastructures in front of us. At this time, only the first type of megastructure has been made, the shell world. Shell worlds, also known as hollow worlds, shell planets or mega-Earths, are a type of megastructure built to house large numbers of sentients in their natural biological form, as well as to house ecosystems of non-sentient life in an environment designed to simulate that of a terrestrial planet. Shell worlds are designed to emulate natural planets but require far less mass to create. If you look closer, you can see that shell worlds are typically composed of a surface layer of rock, soil, water, and living things sitting on an immensely strong spherical shell made of materials capable of holding the surface in place for timescales on the order of billions of years. Simply put, beneath its surface lies a number of structures. Its living space is a shell of breathable gases surrounding and held up by a core cell of hydrogen and capped by an outer solid shell. The living space is 2,400 kilometers deep, with a surface area approximately 1,400 times that of Earth. But if the living space were divided into 3.5-kilometer high floors, the usable volume would be about 1 million times that of Earth. Its population is 36 trillion based on assumptions of energy use and black body radiation of waste heat. To control weather, floors are divided with vertical partitions, creating Earth-sized cells 10,000 kilometers across. There's also a steel cap which, under the local acceleration of gravity of 0.02, has to be 500 meters thick to produce a force down equal to the atmospheric pressure up. Therefore, it's a microgravity environment. Let's take a closer look at the different types of shell worlds. First, Type 1, or the medium-tech shell worlds, which consist of a series of habitable shells constructed using the crust of a tectonically quiescent world, extending above and below the surface. Next is the high-tech Type 2 shell worlds, which is supported by gas pressure. Here, each shell is constructed incrementally by creating bubble habs or full airs, which can act as habitats or serve other uses during shell construction and link them into ever-growing rafts, eventually forming a continuous shell. Then there's also the ultra-tech Type 3 shell worlds, where an arbitrary number of concentric layers are suspended one above another, with the only practical limits being the energy requirements for each shell and the removal of waste heat. The different layers can each have very different environmental conditions, but the connecting lift shafts must be evacuated to prevent contamination between levels. Let your eyes feast on this megastructure, as we are now about to go to the year 8654, when the shell worlds are no longer enough to hold human life, so we need a new megastructure, the Dyson Sphere. An engineering project of stellar proportions. As you can see, this is the ultimate solution for living space and energy production, providing its creators ample surface area for habitation and the ability to capture every bit of solar radiation emanating from their central star. According to Freeman Dyson, the British-American theoretical physicist who first speculated about these putative structures in 1960, a shell of this thickness could be made comfortably habitable and could contain all the machinery required for exploiting the solar radiation falling onto it from the inside. The ultimate Dyson sphere traps dark energy inside and reverses the expansion of the universe, or the Big Rip. By manipulating extra dimensions, a Type 4 civilization would create a gigantic sphere where dark energy can reverse polarity, so cosmic expansion is reversed. Outside the sphere, the universe might continue expanding exponentially. But inside the sphere, galaxies and stars evolve normally. Now, hold tight as we're journeying a little further this time. Our destination, the year 12,425, when the construction of the Dyson sphere was long done and it now hosts human life, among others. And as it's ever expanding, we'd need a new megastructure, the Alderson disk. It's a megastructure that's capable of supporting human life, similar to a Dyson sphere. Here, it's neither too dark nor too bright because the sun remains stationary, so there's no day and night cycle, only a perpetual twilight. However, this could be solved by forcing the sun to bob up and down within the disk, lighting first one side, then the other. Computer-controlled Shklovsky grazers mounted on the inside edge could induce vertical motion and would also serve to nudge the star back to center if it begins to stray towards the inside annular edge of the disk. What's more, life could exist on either side of the disk. Though close to the sun, the heat would make life impossible without protection. Conversely, farther away from the sun, living beings would freeze. Therefore, for the entirety of such a structure to be made habitable, it'd have to include a vast number of life support systems. Even without such systems, the habitable surface area could be up to hundreds of millions of Earths for a late Type 2 civilization. How so? Well, an Alderson disk weighs about 6 by 1,033 kilograms, or about 3,000 solar masses. The innermost radius is about 50 million kilometers, just inside the orbit of Mercury. The outermost radius is set at 600 million kilometers from the Sun, about midway between the asteroid belt and Jupiter. The disk is 5,000 kilometers thick, so the surface gravity is 0.14 Gs, like the Moon. The whole would be surrounded by a 1,000-kilometer high wall to prevent the atmosphere from drifting into the Sun. No wonder its useful living surface is amounting to more than 4 billion Earths. You might be wondering what humanity needs all this space for. Well, after the rapid expansion of humankind, there was an ever-growing need for living space, as well as industrial districts to sustain all these people and their needs. Hence, the need for space megastructure arises. Additionally, said structures would prove beneficial in terms of economic growth. For one, studies show that mining in space is set to become a reality in the next 50 years. In light of this, experts predicted that space mining could be one of the most profitable and beneficial industries for mankind in the next half of the 21st century. This explains why the outer edge of the Alderson disk is located near the asteroid belt. It's where droids are diligently working on getting more materials to build the next megastructure, setting up humanity for the journey towards becoming a Type 3 civilization. Now, I hear you ask, how are we going to build those megastructures? Check out this video about construction in space to see how we do this right now and our plans for the future.